It's great to be here. It's my pleasure to be here. And I wear several hats today. I'm coming to you as an alumni of the university. I graduated my bachelor's degree in 1983 and my master's in 1986, a long time ago. But I'm also coming to you as an employer. We're a company, as was previously stated, we're a company that hire UConn grads. Our company is currently at 1,300 people, so we always have openings for grads, and it's something that we're looking. There's a definite need for civil engineers in the world. There's a shortage. I would say there's a shortage in the U.S., and everything I read says the shortage will continue for years to come. So it's a good career to choose. I'm also coming to you as a person who's on the advisory board for the department, so I know quite a bit about the department. The advisory board essentially advises the department on how they run the department and what they do. So I have several hats today. So today I'm going to talk really about careers in civil engineering, and I'll also talk about the Steel Bridge Club that I've been the advisor for a while now, to let you know what you can expect after you graduate. Next slide. So our company, CHA, as I said, we're a large company at 1,300 people. We have about 130 in Connecticut. We have an office on campus and stores. We also have a large office in East Hartford, which is where I work. We do a lot of work in transportation design and bridge design. Those are the two main focuses, but we also do have engineers working on civil environmental, such as site development, surveying, hydraulics, and brownfield management. I'm going to talk mostly about the transportation and bridge because that's my area of focus. And just to say that there's exciting things coming forward. People think sometimes civil engineering is a boring field. It's actually right now a very exciting field. And the next 30 years, it's going to continue to be very exciting. So we'll talk a little bit about that. Next slide. So as I said before, I graduated, next slide, please. I graduated in 1983, and when I started, too far, back one. When I started, we were doing drawings on paper on a board. Actually, I used to have a desk look just like that. It's kind of scary. CAD didn't exist. We didn't do anything. The hand calculations, we had calculators. That was about it. Now everything's done in computers. Everything's done in 3D. Design has gotten much more complex, but it's also more exciting. And one thing we do know in the future, everything will continue to change over the next 30 years. Next slide. One of the exciting things that we have in our world of bridge engineering, and I primarily am a bridge engineer, is the field of accelerated bridge construction. About 15 years ago, there was a move in the United States to replace bridges faster because we had traffic on bridges that we couldn't get rid of the traffic. We needed to expedite construction. So this field, our company and myself have been very involved on a national level. I've written manuals. I've written the national code for accelerated construction. But it's really cool. This is a photo of a bridge in Utah that was installed in 24 hours. It was replaced in 24 hours. So this is the kind of thing we can do. We've taken bridge construction from years down to days and even hours now. It's a very exciting field. It's a big part of what we do these days. In the Northeast, it's very common. And our firm, CHA, is at the forefront. We are basically one of the we are the go-to company in the United States for accelerated construction. Next slide, please. So what about transportation engineering? This is a huge field that's going to change dramatically in the next 30 years. Autonomous vehicles are coming. They're here already. And how will that change the way we do our engineering? And the answer is significantly. The problem is we don't know exactly what's going to change because it hasn't all been figured out yet, which is why we need young engineers to go to school and learn about this and become the people who actually make the rules as we move forward. So things like geometrics of highways will probably change. Signs, we probably don't need road signs anymore. You almost don't need them now with your GPS systems. Traffic signals, we probably will not need traffic signals in the future. Cars will be talking to each other. Do we need more highway lanes or less highway lanes? We don't know yet. It's a very dynamic field. So these photos are cool. The photo on the upper one is from the 1950s showing people doing a board game in their car on the highway. That was the dream in the 50s and 60s. The middle photo is a current driverless car that's being tested right now. And then the photo on the bottom is when I was a kid, we were promised flying cars. It hasn't happened. Maybe it'll happen in your lifetime. Next slide. So one thing our company does with UConn, we collaborate very closely with the university. And one thing we do collaborate on is research. And UConn is a very significant research university doing all kinds of research in all different fields of civil engineering. This is a photo of a research project that is a concept that we developed at our company. The Connecticut DOT funded this research. It's a novel idea of repairing corroded steel girders for bridges using a super high strength concrete, which you can see in the bottom of this photo. We came up with the idea. The DOT funded the project, multi-million-dollar research project. That is a 54-inch deep bridge girder, full scale, being tested to 1 million pounds in the lab. Really cool project, very successful, and we're now actually starting to deploy that. Another thing that I do for the university, I've done adjunct teaching. I've taught several courses in the graduate school, and that's going to continue. And I'm currently I'm helping the department develop a bridge engineering certificate program. It's a graduate level program in bridge engineering that is in development right now. And then what I'll move on to next is, since 2001, I've been the advisor of the Student Steel Bridge Team, and we'll talk a little bit about what that actually is. Next slide, please. Okay, the Student Steel Bridge Team is a competition. It's a national competition sponsored by the steel industry, where students are asked to design and build a bridge about 20 feet long based on specifications that they give us every year. It's a really cool competition. About 250 schools participate, engineering schools. The parameters are, you build a bridge in pieces and you have to assemble it as fast as you can. You want to make the bridge lightweight, but it has to be structurally sound, and it has to be able to support a 2,500 pound load with minimal deflection. So the photo here is a photo of Melissa, actually, who's going to be speaking next. This is our shop we have just off campus, where the students actually design the bridge, and we actually fabricate the bridge. We do welding and drilling and cutting, and it's a great class. No experience necessary. We'll take any student. Freshmen are welcome to join, and we get to build a cool bridge, and then we compete. Next slide, please. So as I said before, I've been the advisor to the team since 2001, a long time ago. The way the competition works is a regional competition held in the Northeast. About 10 to 15 teams compete, and the top 2, sometimes 3, move on to the national finals. UConn has been very successful. We've qualified for nationals 12 times in 19 years, and we've actually won the regional competition 6 times. So we're a very competitive team. We have a lot of fun. We build all different types of bridges. You can see the photos on the right are 3 different bridges that we built in the last 5 or 6 years. If you move on to nationals, the top 50 teams in the country participate, and UConn has consistently been a top 25 team in the country. So we're very competitive, but we don't take it too seriously. We have a lot of fun doing this, building the bridge, and then competing.